Alright, you guys, we're going to go ahead and continue with the second part of our lesson 3.1. And in this case, guys, once again, we're still focused on identifying specific characteristics of quadratic functions. So let's actually get started with this here with the types of parabolas. Now, in this case, guys, whenever we're talking about parabolas are U-shaped graphs in this case. Now, depending on the types of parabola we have, there's going to be occasions where we'll have two x-intercepts, one x-intercept, or no x-intercepts. And for us to visually see in this case how many x-intercepts we have, we do have to take a look at a few graphs. So let's, for example, take a look at this first one. And in this case, this first one does have, in this case, two sets of graphs. It has one that's in purple and it has one that's in green. Now, notice in this case that the graphs, the parabolas in this case, are crossing the x-axis at two different points. If I focus in this case on the one that's purple, it's crossing it at one point here and another one there. So that graph alone, or that function alone, does have two x-intercepts because it's crossing it twice. Same thing if I take a look at the green one here. They both have two x-intercepts, so that's how we determine the amount of x-intercepts. We determine it by the number of times the parabola actually crosses the x-axis, which is this one here. So if we take a look at having one x-intercept, the parabola actually only meets or touches the x-axis at one single point. And for when we have no x-intercepts, our parabola basically doesn't even touch the x-axis. It could come close to it, but it doesn't really touch it. So I actually want to go ahead and talk about these problems. And in this case, for example, on example number 1, it says a parabola intersects the x-axis at x equals -1 and x equals 5. What is the x-coordinate of the parabola of the vertex? First off, let's go ahead and identify what we're given. We're told that there's 2 points in this case that cross the x-axis. These points specifically, and go ahead and do it in this color. These points specifically actually represent our x-intercept. So we actually have two x-intercepts, right? If I were to graph this, let's say I were to graph it, and it doesn't have to be pretty, but we'll go ahead and graph it here. We have the x-axis and we have the y-axis. We have 1, 2, 3, 4, 5, and 1. So we actually have those points here. So name of those points in this case, we have 5, 0, and 1, 0. A few ways you could actually find this, since we want to go ahead and find the x-coordinate of the vertex. The vertex is actually right in the middle of these 2 points. Vertex, you'll find it right in the middle of these 2 points. And the x-coordinate in this case is actually representing our axis of symmetry. And I'll go ahead and just label that as AOS, axis of symmetry. So 2 ways we could do this. I could actually graph it like I did here, and I could count the points. Let's say the distance, 1, 2, 3, 5, 6. And since there's 6 of them, half of that is 3. So I should actually have my axis of symmetry, or the x-coordinate of the vertex, 3 spaces away either of the points. So I'll do 1, 2, 3. We should actually have axis of symmetry there, which is the line x equals 2. That's one way of doing it visually. In this case, algebraically, in this case, we actually have to find the average of the x's, which means I have to add all the x's I'm given. In this case, I'm given 2 of them, and then divide by the amount I'm given. So because I'm given 2, I divide by 2. Right there, I get 4 over 2, which in this case gives me a 2. So that's actually the value for x. X equals 2. So our answer in this case would be x equals 2. Now, applying this, I want to go ahead and now focus on example 2. And in example 2, in this case, it says a graph of a parabola whose x-intercepts are at x equals -3 and x equals 5, and whose minimum value is y equals -4. So we have to graph it. We have to graph it. Now, in order for you to be able to graph a parabola, first point you need is the vertex. we need to identify the vertex in this case. We need to identify the vertex. So the vertex is actually composed of 2 points. It's composed of x and y. And if you notice in this case, they're giving us a keyword, a minimum value. Minimum value in this case does talk about our vertex. So they're saying that we have a minimum value of y equals -4. So that -4 is actually part of our vertex. It's actually the y of the vertex. I'm going to go ahead and write a -4 there. So in this case, I need to focus on finding the x coordinate of the vertex. So we need to find x coordinate. X coordinate of vertex. In other words, our axis of symmetry. And I'll just label that as AOS. So I could do it 2 ways. I could do it like the previous example where I actually graphed it, or I could use the formula. So I'm actually going to show it algebraically in this case. I'll show using the formula. So I'll find the average in this case of the x's. And that means in this case, guys, that I'm going to be adding both of the x's that were given. And since I'm given 2 x's, I will be dividing by 2. -3 plus 5 is 2. 2 over 2 is a 1. So in this case, the x coordinate is the point -1, or actually just 1. So my vertex in this case, this value here, is actually going to be put in our vertex. I'm going to do a different one. This value here is going to be put in the vertex. So I'm actually going to put a 1 here. So let's go ahead and graph this. Let's go ahead and graph it. So I'm going to go ahead and create my graph here. And that's x. Make sure to label your axes and y. So first point we want to go ahead and plot is the vertex. First point is the vertex. So I'm going to go ahead and go to the point 1, -4, and that's 1 to the right, 4 down. And that's our vertex. And then from there, I'm actually going to go ahead and use our x-intercepts. The x-intercepts in this case, where x equals -3 and x equals 5. So those are the actual points of, let me write them up here. Those points are -3, 0 and 5, 0. So let's go ahead and plot them. So I have 1, 2, 3, 4, 5 is here. And then 1, 2, 3 is there. So let's go ahead and create our parabola. Let's go ahead and do that one more time. And that's our parabola. So once again, whenever you're graphing a parabola, the first thing you should be plotting is your vertex. And our vertex is here. And it's the point 1, -4. And that is our graph.